These are example problems 1 and 2 on the ideal gas law sheet. So I've already shown you how the equation goes together. Here's how to actually solve problems using the ideal gas law. And reminder that pressure's got to be in atmosphere, volume in liters, N is your number of moles. So you have to go back to figure out how to get moles. R is always 0.0821. Remember, your temperature has to be in Kelvin. So we got to add 273 to whatever Celsius temperature we have. So first problem, we have 5 grams of CO2 at 35 degrees Celsius and 740 millimeters of mercury. So our pressure is 740 millimeters of mercury. So remember, we got to divide that by 760. Okay, because 760 is 1 atmosphere. So pressure's got to be in atmospheres. So we're going to take 740 divided by 760. That gives us how many atmospheres we have. So a little bit less than 1 atmosphere. Wants to know what the volume would be. So there's our variable we're looking for. N is our number of moles. And we have 5 grams of CO2. So if I was going to do that, I'd say, okay, I have 5 grams of CO2. 44 grams of CO2 is a mole of CO2. So I'm taking 5 divided by 44. So I can just put that in there as 5 divided by 44 if I want to. Or you can solve that and put your moles in, whichever way is more comfortable for you. Our R, 0.0821. And our temperature, make sure we change it into Kelvin. So we had 35 degrees Celsius plus 273 equals our Kelvin temperature, which would be 308 Kelvin. Now it's just a little bit of algebra. Just a little bit of algebra. So I would multiply these 3, divide by this. Okay, multiply those 3, divide by that. So you end up with 0.97 times V equals 2.78. So divide by 0.97, divide by 0.97, and our volume is 2.95 liters. So if we have a gas, it's less than a mole, so that's why we're less than 22.4 liters. At a little higher temperature than standard, and a little bit less pressure. We take up that much space. Number 2 is saying how many grams are there in 2.5 liters of CH4 gas. So plugging in the same ones. Tells us 2.5 liters, that's our volume. And our pressure is 790 millimeters of mercury, so we gotta take 790 over 760. Remember, that's just putting it into atmospheres. It's a little bit more than standard pressure. 790 is more than 1 atmosphere because 1 atmosphere is 760. Our volume, we said, was 2.5 liters equals, we're trying to figure out the mass of CH4. So I'm going to put in N and solve for moles. Moles is not mass, but we can convert to mass from there. And then we have our 0.0821. And our temperature is 73 degrees Celsius. So 273 plus 73 gives us 346 Kelvin. 346 Kelvin. Same type of deal. I'm going to multiply these. I need to divide by these 2 numbers right here. You end up with 2.599 equals N times 28.41. So divide by 28.41. Divide by 28.41. So those cancel. Divide those 2. Our moles are 0.0914 moles. And that's moles of methane gas, CH4. The question wanted to know how many grams that would be if we had 2.5 liters of that gas. So we need to convert that to grams. So every mole of methane is 16 grams. And you end up with about 1.47 grams of methane. So 2.5 liters, which is probably less than a mole, at this temperature and this pressure would be 1.47 grams of methane. Examples 3 and 4 will be on a different video.